Hello, good day. Welcome back and please join in to learn this another session in embedded system design on ARM Cortex M4. I'm pretty sure that you are revising so far and you are getting yourselves familiar with different registers where they are using and where they are used, and also how the different buses are connected to access to any memory locations, etc. If not, then please go back to all the revision videos to get yourselves more familiar with all the concepts. So this class or this session would be easy for you to go through. If not, if you join in one of the internship programs, and the videos will be there for you to learn. So today is day 14. Welcome in. Today we're going to learn about what is UART, and it's divided into two parts. Today's session will be UART transmit, and the next session will be the part 2, which is UART receive. In today's section, this is what you will learn. First, you will learn what is an UART and how that is used in STM32F411, how that is used in communication. And then you're going to learn between the UART versus the USART, what is the basic differences. Then when you want to talk about communication, it will be in the form of transmission or transferring data. To do that, you got to first transmit. So there are few steps that you should learn and you should think, and there are few registers that link to that USART transmit. So you're going to learn that from scratch. You're going to go into deep into all the registers, and you're going to copy all the addresses, etc. So you will learn all the steps. And then I'm going to take you to the demo session where you will learn to write all the code from scratch from line 1 to end, and you will be viewing that output in any hyper terminal. But I will also show you how to download Arduino IDE, because that is very good to learn as well, and that's coming in other course sections. So that's where we will verify the output for today. So let's get in. Before jumping into learning about today, I would like to give a small introduction about whom I'm representing. I'm representing A2DG. It's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered over 20 years of experience, and we would really would like to help you all, to put you out there what we went through, 20 years experience and the knowledge. So it will be very useful for you to shape into a better version of you. So at the end of 30 days program, you will be a better version of where you are. So please stick by with us, and you will get to learn plenty of information from us. To convey, it's our mission is to convey our knowledge and our experience to at least 100,000 future professionals through online course. And the main advantage is you don't have to go to a face-to-face class environment. You can study at your own pace anywhere. All you have to have is a mobile phone or a computer and an internet connection. You can access to the videos and you can learn. So that is really one good big advantage. So please stick by us and you will get plenty to learn. A little bit about me. I am Arul Prakash Anbukarasu. You can call me as Arul or API, as persistent as I would like to share my knowledge with you and my experience with you all. I have over 20 years of experience working in few countries, in majoring in Australia, Italy, Singapore and India. And I've been working in most of these industries in renewable energy sector, where there is the power conversion from solar energy, from wind energy, and power systems from lead acid batteries, and network embedded systems that's linked with ATMs, the TCRs and POS, point of sale, banking automation systems, and smart parking operations. In a nutshell, my expertise lies on these three: on embedded systems, VLSI, and project management. So please stick by me, and I will make sure you will get to learn a lot, and you will be a better version of yourself. A little announcement to make. I categorize this into two different categories because of different benefits. All the video sessions that you've been going through, it will be all uploaded to A2DG YouTube channel. In order to be eligible to get a free e-certificate, you got to attend at least 28 video classes or video sessions. At the end of every video session, there will be an attendance link. You got to fill in your details and send it to us, and that will count on your attendance. So after that, we will compare and we'll give you the e-certificate. As part of YouTube regulations, we can't keep all the videos in there, so it has to be removed after 2 or 3 days. So in case if you miss a day and if you want to go back and revise, unfortunately you may be able to not to access to it. But that's where the second category is. I would strongly recommend you and advise you to join in one of our internship programs. And what would the internship professionals will lead you to? It will acquire you a priceless internship certificate. Yes, that is worth a lot. If you get into the interview queue, you will be sitting on top of the rest of the other engineers in the queue, because you are more confident and you already learned about microcontrollers and you know about registers. That's what basically is programming with registers. So you got that internal knowledge, and you got this 30 days platform behind you that where you learned everything, and this puts you on a right frame of mind, and you would be able to answer any technical questions or even any psychological questions, whatever, because your mind is fresh with full of ideas and full of information. And after you land on that first job, your senior engineers and your product managers, your project managers will consider you as a big asset, because you already did your hard work, hard yak to put through those 30 days of learning. So therefore, in the industry, they don't have to give you a basic setup process, because you already know which IDs and where registers are and how you can program, etc. So therefore, they will just quickly jump on and assign you into projects. But I don't want to scare you, but these days it won't happen like that. Still, you will be able to learn from the senior engineers. They will take you through, but I'm just sharing my experience, what I went through. Not only that, you will get your own login, so you can log into our learning management system portal and you can go through each and every day session. And as soon as you complete one session, if you hit on complete button, then that will record your attendance for that day. And at the end of the course, the software will know that you learned 30 days worth of programming and course contents. Then the system will generate you and give you the certificate. So that's really priceless. And not only that, on top of that, you will get access to unlimited times to all our PDF materials, the course materials, all the source codes. You can go back and refer and you can practice with those source codes, and also unlimited access to course videos. For instance, you can pause it, and if you got some other emergency situation to handle too, you can go to that and attend and come back, and the videos will be there for you. You can revise and recap and forward and watch it all. And in the learning process, if you feel like if you got stuck anywhere, please contact our backend support team, and they are really good team, and they would be able to assist you to take you further in your education pathways in there. These are all the materials required, and please contact Pantech Solutions. They are a big manufacturing company and they would be able to help you to acquire all of this. Must is the STM32F411RE nuclear board. The more you start to practice yourself hands-on, the more benefits you will get. So please invest your money into buying these things. And I keep saying this to you, this won't stop at the end of this course. You can take this module, the hardware, and you can create your own design. You can create your own project. So it is money worth well spent. So please buy all this. So shall we get to communicate and see what the day unfolds for us? Let's get in and see what the communication is all about for us today. Today we're going to learn about UART. It is a communication protocol. Most of you would be knowing by now through your engineering degree course curriculum. UART has a abbreviation, and it stands for this. In case if you have forgotten, I'm just giving you a recap. If I'm repeating myself, sorry. Just to give you a little bit of introduction, I'm starting with this. UART stands for Universal Asynchronous Receiver and Transmitter. It is a widely used communication protocol if you take in terms of communicating between microcontroller to the other microcontroller, or from a target microcontroller to a host PC, which is the computer, and also you are targeting the FPGA board to another communication board. So likewise, UART can be also used in all those useful communication, and this UART also has been called by other names. For example, you will hear us in the industry, they'll call us serial port or COM port or RS232 port or RS485 port. The basic difference with the RS232 and RS485, we are talking today in terms of communication. When you think of communication, it's either data is involved or other form of communication like video or verbal, that sort of communication. But we are learning about coding, and therefore a large data of communication involves here. When you talk about data, then you have to transmit the data and you have to receive the data. So that's the main purpose of the UART. And RS232, to transfer that data, what you want to transmit, it can cover up to areas from 3 meters to 10 meters. So that's roughly the basic range. But if you want to send your data for long range distances, then you have to think about going to RS485. That's covered for large distances. So as I said, it's very common and very simple to use. Why it is very simple? It has only 3 wires in communication. Those 3 wires are transmit, receive, and ground. So all these 3 pins are used to communicate for data transfer. So this is all about UART. Now we're going to know about the differences, the basic differences between the UART and the USART. As most of you would have learned all this through your engineering degree, but I'm just giving you a recap. UART you already learned just a bit. And what is USART? USART stands for Universal Synchronous Asynchronous Receiver Transmitter. And what is that involved? As you know, in UART and USART, you have to transfer data or send data from one section to other section or from one machine to other machine. Therefore, a data communication happens. And there are 2 modes of communication protocol, a serial mode protocol. One is UART and USART. In USART, all your data will be synced with a clock signal. So for using USART, you need to have a clock signal, and every data will be synced with that clock pulse, and every data will be linked to that and transferred. Whereas in UART, you don't need a clock to sync. You can just use a frame bits with a start bit and a stop bit, and you can transfer the data. But that's where it requires extra bits to transfer data. So that's where USART is really handy, because you don't need that extra bits. When coming to memory allocation, memory storage, those extra bits all count. So USART is really good. And this is the timing diagram that we are going to learn about it today. When you want to send data serially, there is 2 different sort of communication. There is a synchronous communication and there is the asynchronous communication. In the synchronous communication, you can transfer bulk data in a frame structure, because it's going to sync with your clock signal, and you can keep sending data because it's going to sync with the clock and it will just push through the data. Whereas in asynchronous communication, you can only transfer to a byte-sized data in the frame structure. So you need extra bits to transfer. You need to have a start bit and 1 or 2 stop bits with a parity bit for checking your error functions. So this is basically the 2 different way of communication. You can do via asynchronous or by synchronous. So this is the basic difference when you talk about 2 communication standards of USART and UART. And this is what it explained here. Asynchronous transfer does not require clock signal. However, it transfers extra bits, that is the start bit and the stop bits. So that adds more to the memory allocation during data communication. Whereas In synchronous mode, you don't need these extra bits, start bit and stop bit. Instead, your data will be synced with the clock signals, therefore the clock signal is required. So this is the basic timing diagram, and eventually you will learn in the projects that how this is all transferred. This is a simple block diagram to illustrate about how the actual communication happens. This example shows two UART communication ports in two different areas. Again, you have to first make sure your microcontroller and your PC are compatible to use UART or USART mode. Most of the PCs have serial communication, so you don't have to worry much, but still it will have that three-wire communication, the transmit, receive and ground. So most PCs will have that, whereas in some microcontrollers you may not have the support of USART. It may have an UART. For example, 8051 has only UARTs, it doesn't have USART. So likewise, you have to check with your microcontroller and be familiar with what communication mode that microcontroller is used. So in order to target or in order to transfer the data communication, for example, in this example, it's shown from communicating from my FPGA board to a host PC, that's a computer. So for example, if you want to transfer the data from UART transmit pin, it has to be connected to the UART of the host PC on the receive bit pin. So you can't transmit to transmit. So once you hit transmit, it has to receive on the other end. And once that's received, then it has to transmit from here to get to the host or to the previous location. So likewise, the host PC from the transmit bit, it will send that data, and the UART receive pin on the Xilinx FPGA will get the data. So this is how the transmission happens. And when we talk about communication transmission, the one main thing is you have to maintain those pins on the same speed. In other words, you have to maintain those two USART pins on the same baud rate. What is baud rate? As you all might be knowing, baud rate is nothing but transferring bits per second, transferring data bits per second. So that's what baud rate is. And as you all know already, there are plenty of baud rates out there, but the standard one everyone mostly uses the 9600 standard baud rate. So if you set this baud rate with 9600, then this has to be set as 9600. Otherwise, there is no data communication, there is no transfer or receive happens, because for a start you will get plenty of errors and you won't even start to communicate to send any form of data. So please make sure both sits on the same baud rate, nothing changes, maintain the same speed. So that's what really counts. Now let's move on to learning about different parameters that's associated with UART and USART. As most of you would know, there are different baud rates. Most commonly heard baud rate that we know is 9600. There is 19,200. There is 115,200, and there is others. Generally, the data bits come in 7 and 8 bits, but most widely used is 8 bits, but there is also 7 bits. And there is also parity bits used with on and off. This is where you can get to use your odd and even parity to check for your error parameters, error checking. And also for data transfer, you can also use stop bits. In general, it will come as 0 bits, you don't need anything for USART. But in terms of asynchronous, if you want to transfer the data, then there could be, you need occasionally 1 bit or 2 bits to tell the microcontroller that data has been received or transmitted, and then it stops. And also there is 3 different flow controls, none on chip and hardware, and this course is all about hardware. You are targeting the hardware board, and make sure when you start to program, you always connect to your hardware, otherwise it will throw the error. So these are all the when we talk about data communication, you are trying to send data from one communication to other, from one machine to the microcontroller, or from other microcontroller to a host PC, or from FPGA board to microcontroller reward board. So for that you got to memorize, you don't have to memorize, but you got to be aware of using all these 8 steps to transmit data successfully. So this is what you're going to learn, how the transmit bits are used in terms of this STM32 F411 bit microcontroller. We're using Nucleo F411RE board. These are all the steps. First, you got to enable clock access to GPIO. If you cast your mind back to that LED blinking project, you would understand you have to enable that clock first, so that the microcontroller knows at which port that input or output is coming from. So that is why the user needs clock access to tell or alert the microcontroller. So that's a must. And every port and every peripheral is associated with internal registers, and that's how you can write a program. You have to write program to set those registers or enable or configure those registers. So the first step is to enable the GPIO port, where the USART will be configured with any one of the ports. We are taking as GPIO A, it can be GPIO B, C, D, whatever, but as a standard of practice, we'll start with GPIO A. So this is where if you want to enable the clock, then you got to learn which bus is connected to which port and which peripherals are connected to which bus and how that's communicated to the microcontroller. So I'll show you that in the functional block diagram, where how the ports is connected via the bus and how that's connected to the microcontroller, that you will learn shortly. And the second step is to enable clock access to your USART for data transmission. So again, you need to go to that register, and you need to see where that's communicating to which bus, and you have to enable that bus. And then now you got to set your the third step is to set the port, whichever port you are using, you have to set that to an alternate function mode. As you learned from previous sessions, every port can be used as an alternate function, meaning it can be used as an input, the pins that associated with all the ports. It can be used for input, it can be used for output, it can be used for alternate function mode, or it can be also used for analog mode. So there are basically 4 port modes that you can use and set and configure those. So when you say PA2, what is that stand for? I'm sure most of you would know by now. It is nothing but port I and pin 2. So you got to set port I and pin 2 to alternate function mode. I'll tell you why we are learning only PA2 today in the next slides. The fourth step is you have to set what type of that alternate function is going to use for that particular pin. So you got to use, today we learning about user transmit, so that has the alternate function of 07. So you need to set this port as alternate type and link with the memory mapping, alternate function mapping as AF07. Then the fifth step is you have to configure the USART module, and then the sixth step is you have to configure the baud rate in order to maintain the constant, the same speed, not constant speed, the same speed as it transmit to receive. And then you need to, the seventh step is to configure the transfer direction. You got to tell whether you are using it for transmit or you are using it for receive. So that's a must there. And then make sure finally you enable that USART module, and that will start to communicate with the data transfer. So these are all the 8 points that you have to, or 8 steps that you got to really familiar with before jumping on to writing a program. So now let's go into IDE, and I will show you step by step. You're going to write every line of program, and I'll going to explain to you all the basic things that you need in the IDE, and you'll learn for yourself. Just before going there, I would like to show where I'm taking all this reference from. So if you know, you got to download all those reference manuals, and if you want to see how this USART is communicated, you need this block diagram. And this is the block diagram that's in the reference manual on on the data sheet on page 14 or 15. If you go there, you will see this. This is the outzoomed view. So once you zoom in, this is where the UART lives. So it has 3 USARTs: USART 1, USART 2, and USART 6. For our learning today, we're going to use USART 2, and that USART 2 is connected via APB1. APB is nothing but it's a peripheral bus, advanced peripheral bus, APB1. So I'll show you where in the data sheet. So I'm inside reference manual, so I'll go to data sheet. I downloaded all of this. So if you go to page 14, this is sorry, I think maybe 15. Oh, sorry, 14. I can't type, sorry. Okay, it's on page 15 on the datasheet STM32F411RE. I'll zoom in for your reference. So if you see this functional block diagram, this is the ARM Cortex M4 microcontroller, and that's connected via the AHP bus matrix, and that's bus matrix is connected to AHP1 advanced high performance bus, and that bus is connected to various ports. So in order to communicate from any ports, or in order to communicate anything that's listed with all the pins, you need to enable this bus, and to enable that you need to enable the clock first. Then today we are learning about USART and data transmission, data communication, and we are using USART 2. And if you scroll down in the same functional block diagram, that's where the USART 2 is, and that's connected and interfaced via advanced peripheral bus 1, and you got to enable and give clock to this USART 2 because we are learning about USART, and therefore it needs a clock to synchronize your data when you start to transmit. So that's the purpose, to enable this clock. And if you go there, then you will learn that this is communicated via this bridge, and this bridge is connected to the AHP1. That's how it communicates to the microcontroller and so forth. So you get the transmit and the receive by this way. And as you know, every GPIO pin will have associated GPIO purposes, and this is where the alternate function is. And I'll show you this. Every pin, as we are learning today, we are learning about port A2. Why? We are learning about USART2, and we are transmitting the data. So every GPIO pin can be used for alternate functions. So that means the same pin can be used for various purposes. For example, the same port A2 pin 2 can be used for timer 2 or timer 5, timer 9, I2S or event out. So it's a multi-purpose, if you like. It's the same pin, depends on how you set. It can be used as for different purposes. So that's what the alternate functions are. And again, if you go to the data sheet, you will see this table. I'm sure it is page 47, I think, or 46. Sorry. Okay, we need USART2 TX. Okay, this is what we need. So it is on page 40. If you go there, this is the alternate function PA2, port A2, and you're going to set that as a USART pin, as a transmit pin. It is on table 8 on page 40. If you go there, this is the pin definition, about to say which GPIO pin can be programmed for which. So these are all different packages. It comes in different package. Again, in this package PA2, whatever you are using, you need to set that pin as that. So likewise. So if you zoom in, the registers that's going to connect is the CTS, which are not learning today about. We are learning about USART transmit. So you got to use PA2. So that's why today we're going to concentrate on PA2, the port A, pin 2 as transmit bit. And then we were just learning about alternate function, how one same pin can be used for different functionality, and how it can be mapped when you want to communicate with the alternate function to the microcontroller. We're learning about port A2 because we're going to use this as an UART2 transmit pin. And if you link in this table PA2 and USART2 transmit, it's using AF07, alternate function 07. There are alternate functions from 00 to 15. So if your bits, or if your pin lies between 0 to 7, then you need to go for alternate function low registers. If your pin belongs to 8 till 15th bit, then you have to go to the alternate function high registers. So that's the two different regions that you should consider about. And this is about the previous slide. So we're going to set this as the alternate function as the transmit pin. That means this is bit 0, on the port register. This is in control status register, whereas I'll show where this is control status. It will be on the reference manual. I think on page. Okay. While I'm here, I'll show the clock as well. Just going a bit fast to get to the address that I wanted to show. Just one sec. Okay, this is the peripheral that you want to enable first. HB2 AP1. Okay, this is the USART2 that we're going to use. RCC. It is under RCC and APB1 USART2. Bit 17, you need to enable that pin. APB2 RCC PDCR, you don't need that. Trying to get to the control register to show you how the alternate function is mapped. System config. This is all system config. Alternate function GPIO. Okay, you will see that in the GPIO. Sorry, I forgot the page number, so I'm doing the hard way. So this is where the your information that if you already gone through, then you would know exactly which page to go. Otherwise, you can do search there, but then yeah, there are a few other ways that you can go about to learn where exactly everything is. So I'm just taking you via the. Okay, this is the port mode that you have to register. You need to set these register. This is the port A, pin 2. This is pin 0, pin 1, pin 2. And you're going to set this as alternate function. So you need to write 10 in this mode. So mode 2, you got to write bit 5 as 1 and bit 4 as 0. That you will learn in the program. I'm just showing while I'm here looking at the registers. Speed registers, it's a pull up, pull down register. We don't need the data register for here. Want to show you, okay. This is the register I wanted to show you. It's a GPIO alternate function low register, meaning the alternate function selection for port. If the output is between 0 and 7, so it's 0 and 7, it's a 32-bit. So you need to go with, that's port A, pin 1. As you know, STM32F411 has 16 bits of this port, GPIO port, so you can use that. So port pin 1, pin 2 and pin 3. So you need to use these 4 bits. So you got to use from the functional mapping, you learned AF7. So you got to set 0, 1, 1, 1. So that means bit 11 will be 0, bit 10 will be 1, bit 9 will be 1, bit 8 will be 1. So this will represent your function map with the port as 0, 111. That's the GPIO registers. Okay, so there you go. So the next one is there is a different baud rate calculation. So when you write your want to know which baud rate you wanted to put that in the calculation and use it in the program, as you know, the going by the previous session, this STM microcontroller peripheral clock is 16 megahertz, so that is the 16 megahertz, and we are considering to use the baud rate as 9600. To calculate the baud rate, this is the formula. So it is peripheral clock plus baud rate time divided by 2, the whole divided by the baud rate, and that will give you a baud rate register calculation. So we are learning about BRR, and this is the formula. So if you do the math and if you calculate and everything, you will get the value, you end up getting 1667. And if you convert this binary 1667 decimal value to hex, this is what you get, 0 cross 0683, and this is what you have to load into the register, which you will learn shortly in the program. Okay, let's go into IDE, and I'll show you how to write program from scratch. So let me minimize this. Let me minimize this now. Minimize this. I already opened IDE, as you can see, it's already opened. So if you haven't opened, then at this time, this is a very good time to check whether your board is connected with the computer. So as you can see, the LED is on. I communicated this board to my computer via the USB cable. So my hardware is ready, and my programming will start now. So I'll take that view off so you can see the screen. So once you open, this is on the previous example, so you have to go to File, starting as new project, File, New, STM32 project. I think we are going on a bit, so why don't you go and have a short break, and when you come back, I'll take you step by step, line by line, and I'll teach you how. So go and enjoy that short break. I will catch you shortly in about a couple of minutes, and go and have some nibble to have a bite on. So I'll catch you shortly here.